So I wanted to walk through one of the problems on the worksheet. I think this is problem A in activity 4. And I wanted to go through and we'll show you what the product was and do a general step-by-step mechanism of SN1, or SN2 and SN1. So this is going to be an SN2 reaction, right? Because you see that you have a non-tertiary substrate. So that here's the carbon connected to the alkyl halide, or to the halogen. And it's only connected to 2 other carbons, so 1 and 2. So it's a secondary substrate. And you have a strong nucleophile, so something that's negatively charged or whatever she gave you on the list that she said was strong. So first I'm going to show the mechanism. In the book, it uses the curve arrows, so I think this is fine, although I don't really think... well, since they use the curve arrows, they must be right, but I don't really feel the need to use curved arrows. So what's going to happen is you're going to have one of the lone pairs on the nucleophile, it's like the hydrogen sulfide-ish. It's going to attack the carbonyl connected to the halogen every single time, and then the electron pair from the halogen is going to be displaced off of the carbon and halogen bond and onto the halogen. So it's just a substitution. It just replaces the chlorine. So that brings you to this weird, funky little transition state that I try to show you guys. I don't know if she's going to actually have you draw this, but I still think it's important to know about it. Let's see. I'm trying to figure out how I want to draw this. Okay. This is going to be difficult. This way. I can still show it. All right, so if you're ever trying to draw these transition states, just use the line bonds. And you're always going to want to have, before you draw any dashes, you're going to want to have 3 things connected to your carbon that was originally connected to the halogen. So here's a carbon that was originally connected to the halogen. So this carbon right here is just this one right up here. And so the chlorine's gone, or the chlorine is still partially attached, I'm sorry. So you draw the dashes up here. The chlorine's still partially attached, and then this the nucleophile is coming in to attack it. And so these attachments have partial negative charges. And this carbon now, it's almost like it's an anion or a carbocation, but not really, because it has these attachments. So it gives it a partial positive charge, and these partial negative charges cancel out the partial positive charge in the transition state to preserve the net charge of everything else. I think if that's right. Well, technically, between your reactants, you have a net negative charge, right? Because you have the nucleophile, which is negatively charged, and the neutral substrate. So overall, you should get a net negative charge. My bad. But just keep in mind that everything is accounted for, and they draw this funky symbol, I think, something like this to signify it's a transition state, and then this transition state eventually is transformed into the final product. So I'm just going to draw an arrow up here. And just know that in this case, with SN2 reactions, because of the way or the direction that the nucleophile has to come in to attack from the opposite side of the molecule, you're going to get inversion of the chiral center. So your product should have an alternation between the wedges and dashes that were originally there. So you see that before the hydrogen had the dash, right now is a wedge, and then whatever was attached to the alkyl halide carbon now has the dash in the final product. So basically all that happened here was the chlorine got switched out for this SH, and it just inverted the stereochemistry. So this would be like, if this were the R, then this one would be S. But I didn't actually go through and figure out which ones they were. So that's SN2 in a nutshell, the mechanism and everything in the reaction.